If I write something down, you write it down. If I circle something, you circle it. At the top of this paper, write down informal proof. Right now, since we're just learning what proofs are and theorems and postulates, we're going to be less strict about what is considered a justification or what a proof actually looks like. Every course is different. Every geometry course is different. Every teacher is different about what they require for a proof. But most proofs start with the givens. In order to get credit for the givens, they got to show up in my diagram. So when I see 117 angle 2, I'm going to put that directly into my picture, my diagram, and I'll circle it. If I've circled something, that means that it should stay there. It's set in stone. It's assumed to be true because it's given. Let's put in 80 for angle 9. 80 degrees, angle 9. Let's circle it. What other piece of information is in the given section? Emily? Parallel. How do we show parallel in a diagram? Put a couple arrows in to show that A is parallel to B. Just doing that will get you partial credit. If this was worth 10 points, that'd be worth 3 points. Just knowing how to put the givens into the diagram.
There we go.
Down here, write down conclusions and justifications. Every few years, textbooks like to change these terms. This could also be statements and reasons. Basically, column 1, you say something. Column 2, you say why you said it. Let's put some rows in here, some lines. On a test, I will give you many lines. It does not mean that you have to use them all. They're just there in case you need the space. Everybody's proof is going to be a little bit different. What was the first given? Measure of angle 2 equals 117? Even though it's given, we still put it into our proof. We have to treat this proof like it was a recipe. You can't leave things out of a recipe, so you can't leave your givens off of the beginning of your recipe. What was the second one? Angle 9, and that was 80 degrees? That was given. And A parallel to B, also given. Sometimes you'll see all the givens on one line. Sometimes they'll be separated. For our beginning proofs, we're going to put them at the beginning. When we get to our 15-step, 20-step, 25-step proofs, we will write these down as we use them. Right now, just put them at the beginning. Don't lose sight of what it is that we are trying to prove. That is going to end up to be the last line of our proof. We're aiming towards this. This is our goal. It doesn't mean that it's true yet. It could turn out to be false. So I'm going to put an arrow down here at angle 11, write 143, and put a question mark. I'm not going to circle that one. I don't know if it's true yet. Most of the time, it is true, unless we're doing an indirect proof, which we'll get to later. Your job is to get from here down to here and somehow prove that that's 143. Raise your hand. Tell me one thing you can tell me based off of that being 117. Chase.
4 is 117.
4 is 117. What's your justification?
Because
Why is 4 equal to 2?
the vertical angle.
So, he told me measure angle 4 equals 117. For this informal proof, we're just going to put new information over here. That was new information, and he just said vertical angle pair. Later on, we're going to be a little more specific with the wording for that justification. That's fine for now.
Yay.
Let's go back up. It would be good if we moved down this diagram to this area. Somebody raise their hand, tell me how to get down to this area. Emily? Give me just one. 6? So you're saying this is 117. What's your justification, Emily, for that? How do you know that that's 117? More specific, which one of those? Corresponding angles, alternate interior, alternate exterior, consecutive interior. With which one? With 2. Right now, I don't care about specifics like 6 and 2 are the ones that we're looking at. As long as we write down that 6 is 117 and we write down that that's corresponding, that's okay. Corresponding angle pair. In a more formal proof, we might want to write down that we're saying that angle 2 is congruent to or equal to angle 6, and those are the corresponding pair. This justification is actually shorthand for a big, long if-then statement. The statement would read, if 2 parallel lines are cut by a transversal, then the corresponding angles that are formed are equal. Instead of writing all that, we're just going to write corresponding angle pair. We've moved down the chart. We're down at angle 6. Can somebody jump me into the triangle? Yes, sir.
Angle 7 is 63 degrees.
What's your justification?
They're a linear pair.
Linear pair. So I'm going to write that. I'm going to write measure angle, was it 7?
Yes.
Equals 63, and that was a linear pair. We have not officially stated that a triangle is 180 degrees, but I'm telling you, a triangle is 180 degrees. We'll get to that in chapter 4, but I want to use it for this proof. Come back up. If a triangle is 180 degrees, and that's 63, and that's 80, can I figure out angle 10?
Yes.
What would I do?
Subtract 63 from 180.
Subtract 63 and 80, or add those two together, subtract from 180. You'd be doing something like this. And what does that equal?
37.
37. So put 37 here. What was that? Angle 10. Measure. Angle 10 equals 37. That one. 37. And here we're just going to write triangle sum equals 180. Once we get done with chapter 4, we'll have a more specific way of saying that. Don't lose sight of what it is that you are trying to prove. What were we originally trying to prove? 11 is 143.
That's right.
So is 11 143?
Yes.
Yes. We feel confident that we can write that right there. We'll write it, measure angle 11 equals 143. Should match prove statements. The last line of your proof better be what you're trying to prove. Why was that 143? Another linear pair? You just did an informal proof based on some given information and a diagram. We figured out that given the circled stuff and the parallel stuff, that's 143. Did we have to do this path? Did I need to go from here to here? No, I didn't really need to say 4 if I was going to jump from here to here. Or instead of saying that that corresponds, I could have said that this and this have what relationship? Alternate interior. As long as you're giving me correct words, correct geometry terms, and you have proper steps, and you're not getting ahead of yourself, it's a valid proof. It doesn't matter if it's efficient or inefficient. This was a slightly inefficient way to talk about this and then come back to here, but that's all right. As long as we're using proper vocabulary, we're okay. Could I have jumped from here to here?
Yes.
What would that have been? Alternate exterior. Then I could have jumped into here. In chapter 4, we're going to learn yet another theorem that will allow us to skip a step in here. Depending on the formality of the proof, you might have to show this information in the proof. You might have to show your algebra work, your equation work. You might have to break that down into how you're solving the equation. On your last test, was there a proof that was equation driven, where you had to talk about distributive property, addition property, things like that? So you can get really specific with your proofs. There's whole chapters of math textbooks that try to prove why 1 + 1 is 2. And break it down. Do we get the idea? Look at what's in the justification column. You've got givens, you've got linear pair, corresponding angle, vertical angle. This is the start of our word bank for what is okay for a justification. A little bit later on, we'll be looking at theorems, postulates. On your test, did you use a couple of postulates for justifications? Keep this with those 3 other sheets. And next class, first thing we're going to do is 1 or 2 more proofs. We might put them on the backs of these pieces of paper.